Hello and welcome to today's review lesson. This first tutorial will review multiplying and dividing rational expressions. So we are reviewing sections 8.4 and 8.5. So when we're looking at this first example, the first thing you must note is that we're multiplying these two fractions. So this time we're multiplying. And when we're multiplying, what we need to do first is factor all locations, all the numerators and all the denominators. So in this case, I have this numerator right here, which is x squared plus 3x plus 2. That will factor by trial and error. It's a trinomial. It factors into x and x, 1 and 2, both the same signs, both pluses. So that's really the only way that it could factor. So I've factored this top location. Let's factor this denominator. This is a difference of two perfect squares. That's x plus 2 times x minus 2. There's nothing much to do here except see that it's an x plus 1. And there's nothing much to do here except see that it's an x plus 2. If you'd like to put them in parentheses, just to remember that we're multiplying everything together, that's great. Once you've factored all locations, now we're going to cancel any common factors from the numerator and the denominator. So any factor that you see in the numerator that is common with a factor in the denominator gets to cancel away. So let's see what we've got here. I've got an x plus 2 in the numerator, and I actually have two x plus 2 factors in the denominator. But since there's only one in the numerator, only one of these can go. It doesn't really matter which one. I'll pick the first one. I don't see anything else that's going to cancel away. I see an x plus 1 and I see another x plus 1, but since they're both in the same locations in the numerators, they don't cancel away. And I see an x minus 2 and an x plus 2. So it looks like we're finished. I'm going to write the x plus 1 as a quantity squared to note that there's two of them in the numerator. And then I'm going to just write the x minus 2 and the x plus 2 in the denominator. And we are finished. So note that we are multiplying these two fractions. We're going to factor in all the locations and cancel out any common factors. Looking at example 2, now I note that I'm dividing these fractions. So the first thing I'm going to do when I know that I'm dividing is I'm going to keep the same first fraction. Nothing's going to change that right now. But I'm going to change the division to a multiply by taking the reciprocal of the second fraction. So now the x plus 2 is in the numerator and the x plus 1 is in the denominator. Once it becomes a multiplication problem, the process is exactly the same as example number 1. We're going to factor in all the locations, and since we've already factored this one, I'll just write the factors x plus 1 and x plus 2. We've already factored this denominator. It's x plus 2 and x minus 2. And these, I'll go ahead and put them in parentheses just so I can remember that I am multiplying everything here. Everything's a factor. And now I can cancel away any common factors. I see an x plus 1 and I see an x plus 1 in the denominator. I see an x plus 2. I actually see two of them, but only one of them can go since there's only one in the denominator. I believe that's it. The only factor remaining in the numerator is x plus 2. Now it does not need to be in parentheses since there's nothing next to it. And the only factor in the denominator that's left is x minus 2. And that's it. So when you're multiplying and dividing rational expressions, you need to factor everything and then cancel out common factors. But the first thing, if you have a division, you have to change it to a multiplication by doing the reciprocal, of course. Okay, that's this review tutorial, and I'll see you in the next review tutorial. Thanks for watching. Bye-bye.